In this video group, we're going to learn how to find the roots of quadratic functions. We will continue with question number 13. For these kind of questions, we have a few techniques. Let's go ahead and see one by one. The solutions to the equation -1/2 x squared equals to -6x plus 20. This question has two different methods to solve. One is the quadratic formula. For quadratic formula, first we have to put the problem into standard form, which is ax squared plus bx plus c equals to 0, and then label a, b, and c terms and plug it in quadratic formula. Or we can complete the square that we will see soon. Let's start with method 1. So our first step is to put this into standard form. So -1/2 x squared equals to -6x plus 20 is our original problem. We want everything on the left hand side and set it equal to 0. So we can add 6x and subtract 20 on both sides. So what we obtain is -1/2 x squared plus 6x minus 20 equals to 0. Now our problem is in the standard form. Now we can label a term, b term, and c term. Our a term is the number in front of x squared term, which is -1/2. Our b term is the one in front of the x term, which is 6. And our c term is the constant here, which is -20. Now we will plug this in -b plus or minus square root of b squared minus 4ac all over 2 times a. That is our quadratic formula. So x1 and x2 together equals to -b plus or minus square root of b squared minus 4ac all over 2 times a. Our b term is 6, so -6. b term is 6, 6 squared is 36. 4 times a term is -1/2, and c term is -20. All over 2 times -1/2. Here, under the radical, we have -4 times -1/2, which is +2, and +2 times -20 is -40. So under the radical we have -40, 36 minus -40. And 2 times -1/2 is -1. So eventually, whatever this value will be divided by -1, we'll change the sign above. -6 plus or minus, this is going to be -4 divided by -1. We need to know that square root of -1 equals the complex number I, so you need to know this by heart. We know that square root of -4 is equal to 4 times square root of -1. Square root of 4 is 2, and we learned that this is equal to I, so that is 2i. So this expression here equals to 2i. -6 divided by -1 is +6, and we have plus or minus here, and this is 2i. So this is the answer. That is option 3. Now let's go ahead and use method 2 for the same problem. Method 2 is completing the square. Our original problem is again -1/2 x squared equals to -6x plus 20. In the completing the square, our very first step is to make sure that x squared term has the coefficient 1. So we are going to get rid of -1/2 by manipulating this equation. And our second step is to keep x terms on the left hand side the constant on the right hand side. Let's come up to step 2 and then continue. So we would like x squared term has the coefficient 1, so we can multiply whole equation by -2, so we obtain here 1. -2 times -1/2 is +1. -2 times -6, we are just distributing this into all terms, is 12x, and -2 times 20 is -40. Now we would like x terms on the left hand side, so we can subtract 12x on both sides. So we obtain x squared minus 12x equals to -40. At this point we need a little bit space because we're going to take the half of the b term, square it, add it onto both sides. So half of b term is 6, 6 squared is 36, and we're going to add it on both sides. Now we obtain x squared minus 12x plus 36 equals to -40 plus 36 is -4. We automatically obtain perfect square trinomial here. So this is perfect square trinomial that we can practically factor out. The template is this. Square root of 36 is 6, and we use this sign here. So x minus 6, the quantity squared, equals to -4. We need x alone, we need to isolate x, so we take square root on both sides. Here square root undoes square, so x minus 6 equals to square root of -4. We have just seen that square root of -1 equals to I, which is a complex number. So, and we know that -4 under the radical equals to square root of 4 times -1 square root. This is equal to 2, this is equal to I, so this is equal to 2i, but we need to put plus or minus because we take the square root of this. And x minus 6 equals to this. Now we need x alone, so we add 6 on both sides. So what we get is x is equal to 6 plus or minus 2i. That is our answer. So that is the same answer as we did. You can go ahead either quadratic formula or completing the square method, depending on the problem. For example, if your b term is not an even number, if it is not a nice number, then you can't take the square root of it and then distribute both sides. If it is an odd number or fractional number, then this method will be tedious. Quadratic formula is eventually just irons up everything. Just you can go either method. We will see different techniques in different problems as well. Number 14. A solution of the equation 2x squared plus 3x plus 2 equals to 0 is, those are the options. Again, we have two methods as we said, either quadratic formula or completing the square. Here completing the square won't be easy because we have odd b term and half of this will be some decimal number. So let's go ahead and use quadratic formula. It is already in the standard form, so we can directly label a, b and c terms. Our a term is 2, our b term is 3, and our c term is 2. A term, b term, c term. Now we're going to plug it in here. Negative b term, 3, plus or minus, square root of b squared is 3 squared, which is 9, minus 4 times a term times c term, all over 2 times a term. That is equal to -3 plus or minus 4 times 2 is 8, 8 times 2 is 16, 9 minus 16 is 7. and it's going to be -7 because negative number is bigger here, and 2 times 2 is 4. Now what we obtain is we can separate this -3/4 plus or minus square root of -7/4. We don't have it in our options, so square root of -7 can be written as square root of 7 times I, because this is equal to square root of 7 times square root of -1, and square root of -1 goes out as I. And we have 1/4, so we have the answer there. Okay, so that is equal to x equals to -3/4 plus or minus 1/4 I times √7. So our option is 1. So you need to check what type of options you have, and you can manipulate the answer and make it look like one of those answers. Question number 15. The solution to the equation 18x squared minus 24x plus 18 equals to 0. So we're going to find the solution to this equation. We can either use quadratic formula or complete the square. Here completing the square will be more difficult, so let's go ahead and use quadratic formula. I will set the problem and we will use the calculator. So first we need to label it. Our A term is 18, our B term is -24, and our C term is 87. We will use this formula. -24 plus or minus square root of B squared minus 4 times A term times C term, all over 2 times A term. Here you will use your calculator. Using calculator, we obtain under the radical 6 times square root of 158i, which is 6i times radical 158. Once you're done with under the radical above, the rest is easy. So it's going to be 24 plus or minus 6i radical 158, and we have 36 on the denominator. Now we can separate the fractions. 24 over 36 plus or minus 6i over 36 times radical 158. So divide by 6, this you obtain 1 over 6, and 24 over 36 is 2/3 if you divide by 12. So what you obtain is 2/3 plus or minus 1/6 I radical 158. So the answer is 4. In these kind of questions, you can use your calculator directly after you set the equation. And once you do actually under the radical manually, then you can simplify by hand as well. Question number 16. This time we're going to find the solution for 4x squared plus 98 equals to 0. This time we're going to apply different technique because we have just x squared term and a constant. If you have this kind of situation, then set x squared term equals to everything else. So our original problem is 4x squared plus 98 equals to 0. Our first step is to subtract 98 on both sides. So 4x squared equals to -98. Now we need x squared term alone, so we divide both sides on 4. So we obtain x squared is equal to, we can simplify this a little bit, divide by 2, divide by 2. So -49 over 2. Now we need x alone, so we take the square root on both sides. So x is equal to, when you take square root of anything, you write plus or minus. Now, square root of 49 is 7. Because it is negative, we have 7i, because negative 49 is equal to 49 times negative 1 under the radical. This equals to 7, this equals to I, so that goes out as 7i. And 2 on the denominator stays under the radical. Now this is our answer. However, we don't see it on the options. So we're going to go ahead and simplify further. We don't want radical on the denominator, so we're going to rationalize it by multiplying both top and bottom by the square root of 2. So our x is equal to plus or minus, we have 7i here over radical 2. We're going to multiply both top and bottom by radical 2, because we don't want radical denominator, that we call it rationalization. So our answer is equal to 7i root 2. Radical 2 times radical 2 equals to 2. Radical 2 times anything equals to itself. So this is our answer, and it is option 4. Number 17. The roots of the equation x squared plus 2x plus 5 equals to 0 are. Here we can apply either quadratic formula directly, or we can use completing the square technique. Both good, both okay. Here completing the square is easier because our x squared term has coefficient 1 and our b term is even number. So conditions are better here, so let's use completing the square. If you would like to use quadratic formula, our a term is 1, our b term is 2, and our c term is positive 5. And you will plug it in this quadratic formula. Here we will use completing the square technique. Our first step is to keep x terms on left hand side, and we subtract 5 on both sides and keep c term on the right hand side. Now we're going to take half of b term, half of 2 is 1. We're going to square it and we're going to add it on both sides. Now we have x squared plus 2x plus 1 equals to negative 4. Now we have perfect square trinomial on the left hand side. We know how to factor that out. This is our template, and we take square root of c term and we use the first sign we see here. So x plus 1, the quantity squared, equals to negative 4. X plus 1, the quantity squared, equals to negative 4. Now we need x alone, so we need to isolate further by taking the square root. So square root cancels square, x plus 1 equals to plus or minus because we're taking the square root. We know that square root of negative 4 equals to 2i. We know that square root of negative 1 is I. And square root of negative 4 is square root of 4 times negative 1 radical. That is equal to 2. This is equal to I. Now we need x alone, so x is equal to, we subtract 1 on both sides. So what we obtain is plus or minus 2i minus 1. Okay, so we needed 2 roots because it says roots are, so we need to separate this. So one solution is x1 is positive 2i minus 1. The other solution is negative 2i minus 1. So one positive, one negative expression. So our answer is 3. Number 18. Let's find the solution for 3x squared plus 2x equals to negative 7. Here we can use quadratic formula easily, but our first step is to put this in standard form. Don't forget to do that. So 3x squared plus 2x equals to -7. We add 7 on both sides. So what we have is 3x squared plus 2x plus 7 equals to 0. Now it is in the standard form. Now our a term is 3, our b term is 2, and our c term is 7. Let's plug this in our quadratic formula. So our b term is 2 plus or minus square root of b squared is 2 squared, which is 4, minus 4 times a term times c term all over 2 times a term. -2 plus or minus 4 times 7 is 28 times 3 is 84. We have 4 minus 84 makes -80 over 2 times 3 is 6. Now we can separate the fraction. -2 over 6 plus or minus radical -80 over 6. Now radical -80, we can either use our calculator or we can do prime factorization. Divide by 2 40, divide by 2 20, divide by 2 10, divide by 2 5, divide by 5 1. So it is 2 4 root 5. So we know that AD radical equals to 16 times 5 and -16 times 5, and we know that this is 4i. So what we have is, let's simplify this. This is 1/3, -1/3 plus or minus. So radical -80 goes out as 4i root 5, and we have 6 on the denominator. And if you simplify this by dividing 2 by dividing 2, so eventually we obtain -1/3 plus or minus 2/3 I radical 5. So this is our answer. So option 3. So you can label A, B, and C term and directly plug in your calculator, and TI calculator will give you answer directly. Or you can use basic operations and then do manually from here. When you have negative radical, you know that it's gonna go out as I, complex number, and you can do prime factorization for partial radical. Question number 19. The solutions to the equation 5x squared minus 2x plus 19 equals to 9. So here the best way is to put this in standard form and plug in quadratic formula. So be careful about putting this in the standard form. We need everything else equals to 0, so we subtract 9 on both sides. So what we obtain is 5x squared minus 2x, 13 minus 9 is 4, equal to 0. Now we can label A term 5, B term -2, and C term 4. So this is our A term, B term, and C term. Now if we plug this in our quadratic formula carefully, we obtain this. So here be careful that B term is -2. When you're squaring that, put it in parentheses, and don't forget to put negative term in parentheses carefully, and your calculator will give you the answer. You can also do this manually as well. So our answer is option B, option 2. Question number 20. What is the solution when the equation wx squared plus w equals to 0 is solved for x, where w is a positive integer? So here w is a positive integer, a number like 3, 5. So this is an integer. We can factor out this equation and solve for x. So we have common w on both terms, so we can factor out w. And on the first term, x squared is left, and on the second term, 1 is left. For check, you can multiply w by x squared to get wx squared, and w by 1 to get w. When you distribute, you have to get the equation above back. Now, we said that w is a positive integer, so we can ignore it. X squared plus 1 equals to 0. We're gonna solve for x, so we subtract 1 on both sides. So x squared is equal to -1. We need x alone, so we take square root on both sides. So x is equal to, we take square root of this, so we put plus or minus. Square root of -1 equals to I, that you need to know. And the answer is option 4. Question number 21. If a solution of 2 times the quantity 2x minus 1 equals to 5x squared is expressed in simplest a plus bi form, which is the complex number form, the value of b is. So first, let's solve this quadratic equation, find the solution, and then identify a and b. So our original problem is 2 times 2x minus 1 equals to 5x squared. Let's put this in standard form. Let's distribute this. 2 times 2x is 4x, 2 times -1 is -2. We have 5x squared. Let's subtract 4x and add 2 on both sides. So we get 5x squared minus 4x plus 2 equals to 0. Here our a term is 5, our b term is -4, and our c term is 2. Now we can plug this in our calculator. When we plug a, b, and c term in our quadratic formula equation, this is what we get. And in the answer, this part is our real part, which is a part, and this is our imaginary part, b part. And we're going to exclude I. So our b here is radical 6 over 5. So answer is option 2. Question number 22. Solve the equation 2x squared plus 5x plus 8 equals to 0. Express the answer in a plus bi form. Because this is already in standard form, we can label a term, b term, and c term, and plug in our quadratic formula. So -b, which is -5, plus or minus square root of b squared, which is 5 squared, minus 4 times a term times c term, all over 2 times a term. So what we have is 25 minus 4 times 2 is 8, 8 times 8 is 64, 25 minus 64 is -39, and 2 times 2 is 4. Now we can separate this fraction. -5 over 4 plus or minus. So we can take -1 outside as I, because we know that radical -1 is equal to I. So positive 39 stays inside, because -39 under radical equals to 39 times -1 and divided by 4. So if you would like to write better, because you need to express it in a plus bi form, so x is equal to -5 over 4 plus root 39 over 4 I. So this is the answer. Question number 23 is the last problem of this video lesson. The next video will be on using the discriminant, complex conjugate root theorem, and graphing quadratic functions from question number 24 through 36. 23. A. Algebraically determine the roots in simplest a plus bi form to the equation below. B. Consider the system of equations below. The graph of this system confirms the solution from part A is imaginary. Explain why. So let's go with part A. Part A says find the solution algebraically. So we need to find using one of the techniques we learned. Let's put this in standard form first and then decide whether quadratic formula or completing the square. We can subtract 4x on both sides and we can add 10 on both sides. So what we obtain is x squared minus 6x, they cancel, plus 17 equals to 0. Because we have even b term, let's use completing the square. That might be faster. Or you might prefer to use quadratic formula. I will go with completing the square method. Half of 6, half of b term is 3, and squared, 3 squared is 9. So I'm going to add 9 on both sides. X squared minus 6x plus 9 equals to, and I take this 17 to the other side as negative 17. It changed the sign. Plus 9. So I take the half of b term and add on both sides. And just before that, I take c term to the right hand side by subtracting on both sides. Now we have perfect square trinomial on the left hand side, which we can factor out as square root of this is 3, and the sign we're going to use is negative. Negative 17 plus 9 is negative 8. And next we're going to square root on both sides. So this is going to be x minus 3 equals to plus or minus square root of negative 8. Square root of negative 8 is root 8 times negative 1. This is going to be I, and this is 4 times 2, and 4 goes out as 2, that's 2 root 2, so the answer is 2i root 2. And we're going to add 3 on both sides. So x is equal to 3 plus or minus 2i radical 2. Now we found the answer is the imaginary, which is 3 plus or minus 2i times radical 2. That's in the simplest form. Now we're going to consider the system of equations below. Now we're going to graph this using our graphing calculator. When we graph both equations given, which is y equals to x squared minus 2x plus 7, which is a parabola, and y equals to 4x minus 10, we can see that they are not touching each other. The line and parabola is not touching each other, so that is imaginary solution. So on part A, we can confirm that this is imaginary solution since parabola and the line is not touching each other in the graph.